Let's spend this lesson talking about the design of our applications. I'm talking about design in this case. I'm talking about the overall architecture of the application. First, before anything else, design your app before you start coding. So often we get an assignment and we just start banging away at the features that we know how to do without ever thinking about how the overall design should go together. But that design is really important, particularly in terms of the maintainability and the expandability of the app. If we're going to have to live with this thing for a while, we probably want to design it properly to start. That doesn't mean that you're going to actually spend a lot of time designing the individual classes at this point. What it means is that you're going to start to pick an architecture and choose the appropriate layers. And the number of layers will depend upon the complexity of the application and to some extent the technology you're using as well. Once you've done that, it's also important to decouple your layers so that one layer doesn't necessarily know a lot about another layer, and more importantly, that they don't overlap in their responsibilities. So if you have a view layer, it's responsible for presenting information to the user and managing the screens. None of the other layers should be responsible for that. So if you've got a view layer that uses HTML as its basic markup language, none of the other layers should be creating HTML for you. That should just be a responsibility of the view. When we talked about MVC, we talked about this idea in terms of separation of concerns. It's also essentially the same idea we talked about in Solid in the single responsibility principle of a class. In this case, we're talking about layers, which have multiple classes typically, but the idea is the same. There's still a responsibility for a layer, and we don't want our layers overlapping and stepping on each other for those responsibilities. And when you're designing your application, plan for expansion and feature creep in that application so that you haven't coded yourself into a box. However, don't code for the expansion at this point, just design for it, because the expansion you anticipate today may not be the expansion you actually need tomorrow. So you don't necessarily need to code for it and add complexity that's unused, but you do need to plan for it and create a solid foundation that you'll be able to build off of. So let's talk about some architectures that are commonly used. And we're going to focus on database applications. They're about 80% of the applications written, so it seems a safe thing to do. The simplest that I could think of that's of any use at all is a two-tier application. It simply has a data access layer and a presentation layer. The data access layer talks to any kind of data storage that we have, whether it be an actual relational database or perhaps just a storage file, a configuration file, an XML file. Doesn't matter, just some sort of storage that we're working with. And the data access layer in this case also convert that storage into usable objects. Then we have the presentation layer that will take those objects and work with the user and present them to the user. So obviously this is only going to be used for very simple applications. There aren't going to be a whole lot of business rules, not a lot of logic or calculations or validations or processes that have to be done. The data access layer doesn't have a lot of meat to it in terms of logic. And you could see this perhaps on a mobile device that's a companion application to some other greater application, perhaps a web application on a main server. And maybe that mobile device's data access layer is actually a remote layer. Three-tier architecture is a lot more common. It's actually a classic. It has a data access layer, a business layer, and a presentation layer. And I'm sure you've heard of this. It's a classic design, and really the drawback to three-tier is the presentation layer may become complex. These days we use so many different technologies in the presentation layer. The data access layer and the business layer, those techniques are roughly the same as they have been for quite some time. But the presentation layer has really evolved. We used to use HTML and maybe a little bit of JavaScript. Now we have HTML and jQuery and Ajax and so many different types of frameworks that go along with those technologies that there's a lot going on in the presentation layer. So the three-tier architecture has given way to some other patterns that we've already seen one of. And that's the MVC pattern, the Model View Controller. I won't spend a lot of time on that because we already have a number of lessons on that. If you're interested in that and haven't seen those lessons, do go back and take a look at those. In the Model View Controller, the model can comprise data access and business rules layers. That doesn't mean that you merge them all together into one big old huge composite class. What that means is just that the model will handle the data access and the business rules. And effectively, there are two layers within that model. The view, of course, presents the data, and the controller manages the requests, queries the model, and returns the appropriate view. It also directs traffic, and this is a distinction that we'll talk about in the next one. The view will ask for an action, and the controller will actually do a redirect if necessary, or it will send it to a different controller or a different view. So the controller actually is a traffic cop to some extent. Our next pattern is a model view presenter, which is very similar to a model view controller, except for a couple of distinctions. As you can see in the diagram, the model talks to the presenter, as a model would talk to a controller, and the presenter talks to the view. And that's about the same as a controller talking to a view as well. However, in this case, the view doesn't know anything about the model, whereas in an MVC pattern, the view actually does have the model as part of its references. Also, note that there's a one-to-one relationship between the presenter and the view. So a presenter can only support one view, and a view only talks to one presenter. The model view controller doesn't make any distinction like that. A controller can support, and often does, support multiple views. So the presenter is going to handle all of the UI events for the view, much like a controller. It'll receive input from the users through the view, like a controller. It'll process the user's data using the model, like a controller, and it'll pass the results back to the view, similar to a controller. But unlike the controller, the presenter is decoupled from the view. They communicate to each other through an interface, and the presenter doesn't manage traffic like a controller. It has that one-to-one relationship with the view. So there is a little bit of a subtle distinction there. Our next pattern is the model view view model. In this case, again, we have the same kind of model, and we have a view model that it will talk to instead of a controller or a presenter. And the view model is actually going to be much more chunky than what we're familiar with a controller or a presenter. It does a lot more work because the view does a lot less work. The view often is written in a markup language as opposed to having any particular logic capability at all. It's offloaded to the view model. And the technology that allows that to happen is data binding. And you can also see that the view model has a one-to-many relationship with the view. So a view model can support multiple views. This technology was created for Windows Presentation Foundation, or WPF, and Silverlight. It's used in other technologies now at this point as well. The view model exposes the model data in such a way that the view can easily consume them, and it does that consumption through data binding. So that data is synchronized through binders, and that's two-directional binding, by the way. If there are changes in the view model sees those changes. Likewise, if there are changes in the view model, the view will see those changes. What this allows is the view to become very simple, as opposed to some of our complex views that we see sometimes in a model view controller that have a lot of jQuery kinds of things going on and AJAX callbacks into the controller. Because we're doing this with data binding and often observable collections, our view becomes very simple, and really it's intended to be created in markup language, and that's the way it's done in WPF. A variety of XML is used. So those are some architectures to think about when you're creating your next application.